Hello everyone, and thanks for joining us today. My name's Kelly, and I want to welcome you to our webinar on the new features we have in BlackLight 2016 R3. We have a great session planned for you today by Don Brister, one of our forensic analysts and instructors. We will be showing you a demonstration of BlackLight, covering Windows memory, Windows events logs, new templates for various file types. And for the Apple side of things, we'll be covering Apple system logs, iOS 10 encrypted backup support, and the recents database parsing. After the demonstration, we'll be taking questions, so please feel free to type up your questions in the questions box throughout the webinar. Also, you'll be receiving a recording of the webinar after its conclusion. So let's go ahead and get started, and I will turn it over to Don.
Thanks very much. I'd like to echo Kelly's welcome to have you with us today. What we're going to do is start going right over to our cases that we can start working with. We'll get started with the memories 8 and 10 raw memory files. Basically, what we've discovered is up until now, no one has really been able to figure out how to parse the Windows 8 and 10 memory and extract it in a meaningful way. I have a BlackLight case already created with a Windows 8.1 hyberfill.sys file and a raw Windows 10 memory dump inside. This can be done with just any Windows or Boot Camp partition that's being brought in, or bring in those raw memory files themselves. If you actually just wanted to bring in the raw memory file, it would be done just like any other partition or file. We'd go to the add and then simply add the particular file of interest. Now in this case, what I'm going to do is I'm just going to highlight something here to show you that it's the advanced options that continue with the Windows 8 and 10 memory files. If we look at the advanced options, we see that the items that are displayed that are most important here, the content searching that's done automatically, and the hyberfill, page file, and raw memory dump. The quick scan will get most of the information we need. Now, because I've already done this, I really don't need to go through and reparse the information. Just remember that every bit of data that's created, viewed, or destroyed goes through RAM, including all web browsing activity, maybe some document edits and images that are showing, even things that will never be stored on disk, like currently running items, what files and network connections are currently open. Let's look at the hyberfill.sys 8.1 file that I have. And to look at the data itself, we highlight the top level item. We go to System and Memory. With this, just like as we've been able to see in the prior versions of BlackLight that are showing both Windows XP and Vista, we see the processes, libraries, sockets, handles, and drivers. Now at the moment, we're looking at the hierarchical view. In other words, all of the different processes occurring with their groupings. Anything that I have highlighted in this left-hand side will then show down below. So if I decide to highlight multiple items here and select 3, any libraries, sockets, and handles related to the items of interest will show. What I'm going to do with the 8.1 file here is just show you the overall. So processes, we get the process ID, parent ID, certainly the name that you see here. Start time, sometimes with an end time, path, and the working directory. Now, something to point out with regards to the start and end, the start times and end times, we see that it's in UTC right now. Simply by going to the case information area and changing our case to whatever time zone we want, this same time zone information will come within the processes. So as we have seen in the past with other Windows operating systems, the processes, any of the libraries to include create date, its process ID, path, descriptor, and the load reason, and then sockets, handles, and drivers. I'll look at a little bit more of them as we look into the Windows 10 information. As we look into the carved data, remember that data inside of these files, and the page file itself can have full files or partial files inside. So in the case of this hyperfill file, we'll look at pictures and JPEGs. Notice as this information comes up and I look at the preview tab below, we have portions of picture files that are showing. So remember that as you might be looking at other pictures, other file types, other documents, even SQLite databases. There may be portions, not full carvings of an entire file to be able to look at within that. So let's go ahead and take a look at the Windows 10 information. Again, we'll go to the System and Memory tabs, and then we'll start looking at processes. This time, instead of this hierarchical view, I want to look at all of these items by name. I'm going to go ahead and sort them, and then I am interested in Microsoft Edge information. So just by highlighting these two particular items, I can see their related information below. So by process name, create date, we can see it's December 2, 2015, their name and path information. But in addition to that, of course, with Microsoft Edge, we would expect there to be internet connectivity, which there is. So as we look at the sockets, we can see by date and time what port is open, the protocol, local address on the machine, remote address, and ports that are also listed. And of course, in this particular case, we see that the state is closed on all of these, but you can take a look at the remote addresses that have been accessed, some things that may be valuable to us for us to take a look at a later time as we are doing an investigation of certain information. Now, we'll look at the libraries. We had already seen this, but we can see within the Windows 10, we have the information about Fusion 2.5 is here, an NT layer driver file. The sockets, these would be all sockets related to the entire memory file that have been dumped, not just the Microsoft Edge that I looked at before. So as we had seen already, you might also notice we get some MAC addresses and some port numbers that are available here. Now in the handles themselves, a handle is kind of a generic term for some type of object that's been opened on the system. So it could be a file, a network connection, or a thread, or several different other things. There are some areas in here that might be of importance. So to look at them, rather than doing a find function, I'm going to go to the show filter up here in the upper right. I'm going to look for the type. Now the type we can see in this column right here. I want to look at the type. So I'll pick that, and notice that this double-headed arrow, the drop down, by looking at this information, we can see all of the different types that are listed, not just all available for memory, but all that are actually present inside of this particular memory file. So let's look at Mutant for a moment. I'll apply this, and we'll be able to see all of the items that have Mutant listed. Now, a mutant, Windows Mutant often is used by malware to signal that a machine's already been infected. Not saying this one has, just saying this is one particular area that could be of importance. Now, another thing that might be important to us is symbolic links. I'll apply in this particular area. So recognize that any symlinks on the system itself could actually be listed inside of here and may not have been listed within the system itself. So I'm going to do a Control F or Command F, depending on if you're on Windows or Mac, and I'm going to look for the word volumes. I would swear I could find that. Well, the two I was looking for aren't here. I obviously got my notes mixed up as I was looking at it. We can look at external devices that are here and recognize some of the information. You know, if I remember correctly, I found a Kingston. That's what I was looking for. We can see that we have a Kingston product that's shown in a USB store here. Now, with the information, we can actually locate it. It might actually be in some of our event logs that we'll take a look at later. So in looking at Kingston and looking at my next Command or Control G, I might see some other items that are listed in this particular area. And then in the long run, I can go and look at the drivers as well, looking at the path of the drivers that have been used to determine if they are something of importance to me. Now, certainly I do need to be more aware of memory in recognizing what is important, what's not important, but these are the areas that you can look at. Very detailed, find function, or even the use of our show filter, just like we have been able to do. And as we saw with the Windows 8.1, the Windows 10 also will do the file carving, and we can see a lot of different types of files that are listed in here with, again, either full or partial carvings of them. Now, one of the next areas that I want to show you has to do with a new templating that we have available within BlackLight. So we have zip files, several compressed file types that we have available, several picture types, some link files, videos. Those are already included templates within the newest BlackLight 2016 R3 release. They're written in Python 2.7, which is the default release with Macintosh. Now, in time, we will have them available for both Python 2.5 and 3.5, but right now BlackLight is supporting 2.7. These are templates that can be written by you, the user, and our new user's guide has a method of how to write your own templates with the template structure available for you. So what I wanted to show you here, I've brought in several zip files into this particular case. I'm just going to go over to the browser and pick the zip file itself to take a look at it. Now, I have the file content viewer showing. I have the hex tab over here. Notice at the moment down here in the lower middle right, the data interpreter that you're likely familiar with that would show dates essentially. Now we have the ability to go through and look at what's called the data structure. So by clicking on the file of interest, the zip file that we have a template for, we can look at the data structure. Now notice here, because it's a zip file, we're able to see within that structure all of the files contained within the archive itself. I notice that the term file space name is associated with the file name itself. Instead of having to go through and look for each one, let's go through and see if I can do a find function and find next. So not only was that last file in it, but an F-16 jet over Iraq, New York PD badge. Now I get some Mac OS X information that gives me an idea that maybe this was actually created on a Mac. Roger Rabbit picture, and then finally a Taylor T5 Koa wood guitar. So these are some of the things that we can do specifically with looking at the zips to look at the files that were inside of them without even processing them. Now what I'm going to do is I'm going to go ahead and take us to another area of looking at some of the files that are available, some of the picture files that we have the ability to take a look at, and some of the templating capabilities that are a part of it there. I'm going to start by going into our Mac or our Racer volume that's here and start looking into, let's just go into the media area and the pictures. I have several different pictures that are inside that we can start taking a look at. Now with this, what we now have the ability to do is start looking at records related to different file types. You know, I recognize I would like to go into Josh's downloads. When I take a look at the information, it gives me the ability to start looking at the hex and the ASCII. Now notice down here in the lower left, we also have the ability, if we're searching for information, to start looking either in hex or in decimal on this left-hand side as we're looking for the particular information itself. Okay. So as we look in files such as the GIF files, the JPEGs, they will have some information that are available related to how that template runs, or even as we get over later into some of the records area, what the MFT or the catalog files are able to show us. Okay. Also, as we look into this area, we can see information, let's say in our details and disk view. Let's look at the racer volume, and instead of the data interpreter, we'll go to the data structure, which now is giving us the information related to everything that we see here, the structure of the partition itself. So we can actually see the number of sectors. And as we highlight these different areas on the right-hand side, you might see right up in here, it's rather small, but you can see the colors changing, the relative sector, the number of sectors that's there, and then the next boot partition that's available. These are some of the data structure capabilities that we can see. What I like to do is take you over to looking at the new Windows and Apple system logs. So by going over to Boot Camp in this particular case, I go to System, System Logs. And we'll see what you might recognize, the log file in US and Journal above. Now the EVT or EVTX, the system logs, are down in this area below where the other file system is. Now, there's a lot of information that we can take a look at in here, but one of the things that I recognized was I might want to do a find for the term boot start. I may or may not see the information here in this data column, but if I go into this full data content, and again I can use the find function or I'll just use the find next, notice that it's able to highlight what was that boot start. And each one of these areas, if I click on them, we could take a look at another of these areas and the information allowing us to recognize when was the booting going on. Now another term that might be helpful is sleep or wake. Let me get wake to come up here. So we have a wake time, we have some sleep time information in here as well that could be very, very helpful. So in each of these capabilities, we are able to take a look within each of the portions to see wake time, sleep time. Just as we've done in the past with other areas, we could go up to this area for the show filter to take a look at the information. So whether finding or using the show filter, we can look for specific items of interest or just see what has been going on within the system over a particular time period. We'll do the same by going over to the Racer or the Mac volume. These system logs are the ASL, the Apple system log. And these will have a particular file type, the source file, the ASL, and the name of it kind of gives us an indicator of group, or in some cases, user logs that we're taking a look at within here. Now we can see some areas. I'm typing the USB MSC. Remember that USB MSC has to do with, like the USB store on the Windows side of things, the ability to find connected USB devices. So this area that I have highlighted in blue down below, we can see that it's the vendor ID, the product ID, and information. Now, these items within a system log we already have parsed out and we show in our actionable intel. But here in the ASL log, it may give you something that the system log itself does not have. What I'd like to do is move over to the next feature, iOS 10 Encrypted Backup support. In our actionable intel, and again I'm on the Racer or Mac volume, if we look at device backups, we can see the information here related to an iPhone 5. Now in this particular case, we already know it's way back at iOS 8.4. If it was 10.1, even 10.1.1, we could do an encrypted backup support to where if you have the information related to the backup password, possibly not the same as the PIN code, then that information would be used to decode the information. Now, a word of warning, just 2 days ago, Apple came out with 10.2. They have again changed things and made things even more difficult. We already have a fix in for our 2017 Release 1 version, but get a hold of us if you have a particular issue. We'll see if we can't help with that if you have a new 10.2. But 10.1, 10.1.1 we have supported for encrypted backup support. This is how you'd know it's encrypted, because we don't know before we get to this point. We see the lock icon. It says it's an encrypted iOS backup that requires a password. When we click on that, we get a window that comes up, gives us the opportunity to put the password in. It wasn't built for this that I'm going to talk about, but in reality, you could do some guessing here. There's not a specific time or number of limit that I know of to be able to put in this password. Again, it's the encrypted password, encrypted backup password, not specifically the PIN code. There's no need for us to go through and look at this one right now because it's already been parsed. But I just wanted to show that for you for the iOS 10 and 10.1 backup support. And lastly, as we start looking at information, I want to go over and start looking at the recents information. The recents database parsing, both in iOS and Mac OS X, is something that can help us know what types of communications have been occurring, though it is just a small amount of information. It could actually help prove that there was communication. Now notice in this particular case, I did a find function in our messages area. So communication, messages. Notice it just says it's an incoming recents message. We have a date and time and a phone number. That is as much as you're going to be getting from this. As we look at the recents, we can see down below that it's actually coming from a particular SQLite database. We're able to go within this database and the table called Metadata to start pulling information to place them together to give you the date and time and the sender information. As I look at additional of the recents, we can see the sender is just a 5-digit number. In other senses, we might find like DonnieA01@AOL.com, another one of the areas. Contacts can have the same thing. Now, because I already have a find function running, we'll see that we have these recents items under the service already highlighted in yellow. As we go through and look at these and go through them one at a time, we can see that their information shows up to the right. I would not expect to see any additional information other than what is known here on the left-hand side as first name, because that's what's listed and nothing in addition to that. Now you may also see the same thing in email of recents. Within these recents, it really exists to have who the email was from and what the subject was. Again, the information comes out of a SQLite database that we're able to parse the information from. So again, we get the ability more than anything, just to say there was activity. Now, can we get email from an iPhone? No, we can't. That's not something that can be done without a true full image, but there are things called recents in there. It's not full email, but it again does show that there has been some connectivity, some contact with others, like we have an Angela Moore, we have something from Groupon, we could have additional information from Graham Gibson if we didn't know that name in this Facebook mail. And just like there was over on the Mac OS X, the iOS will have the same capabilities within the recents information of contacts and within the messages information that we can see. So I'll go to the show filter and go to the service and just use recents. That's the one that I want to show, just the recent items. As I apply that, I can look at the information, and again, I can see those same kinds of contacts that were on Mac OS X, except in this case, I only have 4 different communications themselves. Donnie A, a couple of 240 area codes, and a 50472 sender. So this is something that can be helpful to show the contact that maybe you've not been able to prove in another way. I believe that that's something that's going to be very, very helpful to you. With that concludes what we're going to be talking about today for these specific areas. Also within 2016 R3, we have the known Windows system file hashes, the MD5s for Windows 7 through 10. We now have the Internet Explorer 10, 11, and Edge support. We have some social media parsing of uvu, improved kick attachments and iOS message GPS, type down capabilities, and some other odds and ends. And with that, Kelly, I'll turn this back over to you.
Okay, thank you, Don. Let's go ahead and answer some of the questions that came in. The first question that we have is, in Mac OS Sierra, the password is no longer in plain text in RAM. How do we find it?
You won't if it's not in plain text. Let's just make that simple.
Okay, sounds good. Next, we have a Windows 8 and 10 question. Can raw memory be dumped on a per process basis? For example, executable code sections.
There's not anything specific that helps us to do that within this particular area. Now, you're saying dumped. If you're wanting to look at only executable items in here, you could take these areas of processes and then export those particular selected rows as either tab delimited or CSV. Is that what you're referring to? One way or the other, my feeling is we'll find out in a moment, and I'll be able to answer it maybe more fully.
Okay. Okay, next question is there the ability to plot EVTX events on a timeline view?
There is not in our timeline view itself, no. There is the ability to take these particular items and look at them with their start time, but it's not a plotting of a timeline that you would be referring to.
Okay. Another question is, for memory files, is there a preferred memory capture method, tool, or file extension? For example, .dmp.
The DMP is fine. That works really, really well. The particular type of imager that you use really is up to you, whatever has been working for you best. We have a blog that was written, I think back at the beginning of this year, that talks about various types of imaging capabilities and some particular programs that actually have been working fairly well. So you might want to go back and look at that. That was 2016 R1 ROM memory imaging and parsing.
Okay. It looks like that's all the questions we have at the moment. Oh, wait, we just got one more really quickly. Question is, since we were able to decrypt iOS 10 encrypted backup, has BlackLight been able to get around encryption to extract from WhatsApp messaging?
Not to my knowledge. I believe most of these different individual applications have the ability to block information from their cache area. And as far as the encryption, I don't believe that we have that at this point. I'm sure that you could watch our blogs, because when we do, we might yell it from the rooftops if we can make that happen.
Perfect. And then last one, what would you recommend is the best tool to capture RAM?
People have been using FTK Imager and a lot of other different RAM capture capabilities on the Windows side. So whatever you've been able to use, but I know FTK Imager has been one of those. Again, the blog that we have that was written by one of our developers is a great instance of looking at several different ones, so you could look at those different items. Now, even though we haven't looked at Mac memory, Macquisition will get Mac memory. Of course, you can do that from Deadbox, or if it's Livebox, you need to have the admin password to do it. Although we're not yet doing all of the processes, handles, and all of that, it still will do that deep search to look for the different pieces within it. And you can do the searching of the memory itself. So Macquisition would likely be your best imaging tool on the Mac side.
Okay. Thank you, Dawn, for the demo. That's going to be the end of our questions. As you can see on the slide there, we have lots of training courses coming up, so go ahead and check out our training section of our website if you want to attend any of those classes. If you have any more questions or are interested in a trial version of our software, you can contact us at analyst@blackbacktech.com or via our website. And that's it. Thank you, everyone, for attending our webinar, and thank you, Dawn.
You bet. Thank you all for being here.